Okay, good morning, everybody. Hopefully, people are here to actually hear the talk rather than just eating lunch. So I've got 10 minutes to talk about everything you need to know about encryption at rest. So I've been in the encryption and key management space for about 8 years now with multiple companies. So I'm going to talk about basically what your options are in sort of virtualized and cloud environments. We're going to talk about a little bit about key management, some of the threat vectors, the people you need to be aware about and concerned about, your administrators at different layers in the stack. And then the topic that always comes up about encryption is, apart from key management, is performance. So we're going to have a sneak preview of some results that, some tests we've been doing with Intel on their new processors and how hardware acceleration improves the performance of crypto dramatically. So nothing unusual about this picture, standard virtualized environment. So I've got virtual machines sitting on top of my hypervisor. I've got multiple types of storage sitting underneath me. So whether it's direct attached storage, I've got some sort of network-based storage, whether it's iSCSI or NFS, or I've got my traditional sort of storage type arrays. So the problem gets a little more complex, and one of the recommended guides I would say is if you go look at the PCI guidelines on virtualized and cloud environments, two separate documents. One came out in 2010. The cloud guidelines came in about 2013. They're very good at laying out the problem of how you handle your data security in virtualized and cloud environments. So the one thing they get a little stuck out in cloud environments is how you handle multi-tenancy, because where you deploy encryption makes a big difference in how you manage those different tenants. So if we look, so yes, I mean, encryption is very important, not just from a regulatory perspective, whether it's PCI, whether it's HIPAA, whether it's FISMA, all the numerous guidelines that operate around Europe and the rest of the world. So encryption is very important, and people would typically deploy it in the data center if they have some sort of regulatory need. But when they go to public cloud, their attitude changes. As soon as my data leaves the building, I need to make sure it's encrypted. But there's still a lot of complexity here. People still groan. It's too hard to implement. I've got multiple databases across multiple operating systems. Where do I deploy the encryption? What do I use? Traditionally, it's been very expensive. And as I said, the question always comes down to performance. The cost of a data breach is enormous, but I do want to take a hit on performance. And the thing that, this is a quote by Bruce Schneier, who's written multiple books on cryptography. He's implemented multiple algorithms, still regarded as one of the experts in the world on cryptography. And the encryption component is actually pretty much the easy bit. There are various file system drivers, device drivers. This encryption sits inside your switches or on your hard drives. But where you actually put and manage the encryption keys is the complex piece. In fact, we were talking to a CIO of a large bank recently and said, key management is typically where encryption projects go to die. So that's where a lot of the complexity lies. So if we look back to our sort of virtualized stack, there are lots of places you can deploy encryption. So if I start at the bottom, I can have some sort of storage array. I can have self-encrypting drives, which are very popular in notebooks. That's where their most common usage is. I can move a little up the stack, so I can encrypt. So if I've got a sort of Brocade-style switch, so I'm encrypting inside the storage fabric, or I could be encrypting on the file itself using encrypting drives or some sort of software-based approach. Or I can move up the stack further. So we have the potential to encrypt inside the hypervisor. None of the APIs or the hypervisor vendors out there today provide an encryption solution in the server virtualized space. Or I can encrypt inside the virtual machine, and I've got a number of options to deploy encryption here. So if you think about those static data center environments, a PCI environment, I may be deploying encryption further down the stack, but as we virtualize more and we're moving into multi-tenant environments, if I'm encrypting down at the bottom layer, then I potentially got the same key managed by multiple different tenants, which is going to give me a problem. And that's certainly going to be a problem in the public cloud. Plus, if we're deploying encryption at lower layers in the stack, then anyone operating essentially at the hypervisor layer or the storage layer potentially has access to your data. And that's the biggest concern we see in the public cloud today. So if you think about AWS or VMware's hypercloud services, Rackspace, Azure, if you want to deploy encryption, there are basically two options. A, you leave it to the provider, As the picture kind of indicates, that's the equivalent of putting your family jewels in a safe deposit box and giving both keys to the bank. If the provider owns the keys, they have access to your data. Or the other choice, which is more common, is you deploy encryption inside the guest operating system itself. And then you've got basically three choices: at the application level, at the file system level, or at essentially the volume or device level. So if you think about that stack, so if we're talking about encryption within the virtual machine, what we're protecting against, especially in the public cloud, is administrators operating at these two layers. So if I'm encrypting below the stack, my virtual administrators have access to the data. If I'm deploying down inside the storage fabric using self-encrypting drives, every time data comes off the drive through a data store to the hypervisor, the storage administrator has access to the data as well. So in terms of key management, there are basically three solutions which are kind of deployed today. So I think I've got an encryption algorithm used as an encryption key. That encryption key needs to be stored somewhere. So if you think about your BitLocker or some of the Linux solutions, I boot my notebook, I'm there to type a passphrase to unlock it. That's not going to work very well in a server environment, especially the public cloud. So if they get a power outage, those 50 VMs come up. In a lot of the public cloud infrastructures, I don't have a console in which to enter a password, but I really want those servers to come up. So I want them to come up, authenticate against the key server, get their keys, and boot. So where does that key server live? So there are multiple solutions. So the key server could reside in the public cloud. So some of the providers, Microsoft, Amazon, have key management services that you can use. For example, the AWS Cloud HSM. You could spin up your own key server as a virtual machine in the cloud. Or the typical deployment that most enterprises will use when going to the public cloud is they want to hold the keys in their own data center. So they don't want the keys inside the provider space, on the assumption that even how robust the key management might be, they don't want anyone to get access to their keys. The third solution is especially for smaller organizations who need to encrypt their data for whatever reason, but they don't have the ability to manage and store encryption keys on their own premise. There are a lot of small organizations that do everything out of the cloud today, but they don't want their data and encryption keys in the same place. So there are some encryption vendors that provide key management services out of the cloud. So for example, you might use a key server outside of one environment, you've got your VMs in Amazon, VMware, or Rackspace, and somebody else is managing the keys, and that's separated. So what's missing? So the things that people tend to overlook is, I've got my Windows or Linux VM, I've got my data partition, my D drive or logical volume on Linux, so that's where my sensitive data is. I've got it encrypted, so I should be fine. So the bigger problem that most people overlook is the Windows C drive or the Linux root drive or the swap drives. So if you think about a virtual machine, a Linux virtual machine, I can snapshot it. I can basically mount the root file system, add myself as a user, spin up the virtual machine, get in, and I've got access to the data, even if it's encrypted basically at the file system or the database layer. Memory access is a particularly problematic space, so if somebody's taking a snapshot, I'm dumping the contents of memory to disk, so I need to make sure that those snapshot files are protected. As I mentioned, the PCI guidelines around virtualization. So if you look at section 3.8, they talk about, you might deploy encryption, but you've got to worry about all these swap files, snapshot files, etc. Oops. And then performance. So this comes up in basically every instruction. What's the performance overhead going to be? Is it going to kill my applications? And so most of the encryption at rest is basically deployed using AS today. That's the NIST-approved algorithm. That's what most people are using. They have basically hardware acceleration for ASNR. That's been around since about 2008. So I'm going to show you some numbers from a paper we're going to launch at IDF the next couple of weeks. You'll see that as we switch to hardware-based crypto, the performance overhead drops to a negligible amount. And then the other concern is around random number generation. So keys are basically sets of random bits. In virtualized environments, there have been lots of papers describing the lack of randomness. So there are now new instructions on the Intel processor that are fed through the hypervisor to really get you hardware-based random number generation. So performance, the one thing that's typically not talked about, overlooked, is the Cipher mode. So here we're looking at basically raw crypto numbers using AES encryption, but we're using a combination of CBC and XTS. So Cipher block chaining, and XTS is a long-winded name that's hard to pronounce. But if you see, I've got different key sizes, and I've got a difference between CBC and I've got XTS here. You can see there's a dramatic difference in basically raw crypto numbers. And these are just raw crypto, so there's no I/O involved here. So choosing between different key sizes or choosing between different cipher modes is going to get you a dramatic difference in performance. And now XTS is basically being adopted, it's approved by NIST, and that's the standard really for disk-based encryption out there. So just quickly, 3 charts. So the worst possible scenario for disk encryption you can come up with is a single-threaded application just hammering the disk with reads and writes. So you can see on the left, and these numbers are all kind of relative, I've got no encryption, so that's basically the maximum throughput I can get from a single thread between you and the disk. The second chart along is I'm using AES encryption, but I've got no hardware acceleration. So you can see, yes, in this case, performance is dramatically lower. So you are going to get potentially a large hit on your applications. And then as we move through, we see going from CBC to XTS, the performance difference using XTS and using hardware assist is dramatically different. Sorry, my alarm's going off here. And then just quickly, the final chart here saying, as we increase the number of threads, which is typically your database application or any sort of type of server environment you've got there, as we see the delta between encryption and decryption goes down to a negligible amount. So we're running IO zone tests, we're still just hammering the disk, and from a write perspective, we're getting about less than 1% overhead. We're seeing some anomalies, so on some of the tests, we're even seeing slightly better to show that basically, we're operating within a level of noise here. From a decryption perspective, so I'm reading, we can see up to about 7–8% degradation. So it's a pretty small delta, and then if you think about the stack that's sitting on top, so if I've got a file system or I've got a database, then I'm typically caching, and I've got a large cache hit ratio, so that 8% is going to go down to something that's really negligible. So performance has been a concern. Without hardware assist, you can see the numbers are considerably lower. But with the capabilities that Intel and AMD are providing in their chipsets today, we're now getting that performance down to pretty much next to nothing. Okay, thank you.